Hello, this is the second part of intermittent IV infusion assignment video. Here in this case we'll do the calculation at steady state. So again you read the question and then you have to determine which one is peak and which one is T trough. So here you see the dose is 60 milligram, infusion time is 0.5 hours. So in this place you right to realize that in fact the dosing rate or infusion rate is 120 milligram per hour if you need. Then infusion was started, needs to be given at 9, 3, 2100 and 300 hour. And then plasma samples are taken 2100, 2200 at 8. This you can just put in a table. 2100 and then 2200. So which is 2200 is 3.48 and the other one is 1.85. As you can see, this would be your peak and this would be your trough. Excuse me. So first, as it is a steady state, it could be confusing. So first I suggest you to do, you draw a curve like this based on the dosing interval. So we have started at 9 and assume that it is 1900, so 9 and then it goes to 15, goes down, again another dose is 2100, then another dose at 300. So with this, I didn't do a good job in drawing this, but I guess you understand this. Excuse me again. Here you see the sample were taken the 2100. I guess this is my plasma samples were taken at 2100 and 2200. So let's see. And now so if you are taking 2100, first this trough sample were taken here, assume this is here, trough sample, and then trough sample, guess this was taken here somewhere here at 2100. This you take trough sample and then the peak sample was taken at 2200 hour. So as you can see, this was taken in two different dosing intervals. So what we do, we move this to here. So we move this one dosing interval forward. So your trough time is 2100, so you add 6 hours. This should be what? Which would be 2700. That means this. So your trough tempo, the new trough sampling time is 0300. So this is your new trough, assumed trough. Although I hope you understand. Although in reality, in practice, it was taken at in this dosing interval, during this dosing interval, but you are just pushing to that forward. So again, let's make this concept clear again. I have try to explain in the class. So you first dose, first, second, third, and that fourth dose. Based on the equation, your fourth dose, so based on the timing, so you are taken, sample is taken, let's see, do this curve. Okay, so here your time starts at 900, 1500, 2100, and then here you have 0300 hour. So this is your third dose where we take this was taken trough sample, and your peak sample was taken here 2200. So as I have explained, this is in two different dosing intervals. It is in third dose and this is in fourth dose. So for this reason you assume that both of the sample are taken in the fourth dosing interval. So for this reason you add the dosing interval time with the real time, which is 2100. It will be 2700. 2700 means you have here at 3 a.m. So now you know that once you know what time the real time of T trough and T peak, so you know the difference. So now here you plot it again. Here this is 2200, this is 2100, and this is your 030, and then for your so 2700, and the following day you'd give another dose. So this would be how many hours? 5 hours. 5 hours. So T trough, so now you know that T trough minus T peak is equal to, T trough is what? It would be 030 a.m. to or which is p.m. 22 to which is 10, and here 3, so it would be 10 3, that means 5 hours. So this is the difference between T trough. T trough is going to be 5 hours. So now you do the calculation. Here it is the same calculation. K is equal to ln C peak divided by C trough divided by T trough minus T peak. So you know T trough minus T peak is 5 hours. So here ln 3.48 by 1.85 divided by 5. This will give you, I guess it's 0.1264 hours. This is your K at steady state. Explain this. We have found K at steady state is equal to 0.1264. This is the most important parameter for the calculation of the various parameters of intermittent IV infusion. And half-life is easy. T half is going to be 0.693 divided by 0.4 is 5.484 hour. And then Cmax as steady state. Cmax as steady state, again we have to calculate for Cmax as steady state. Here it is easy to calculate. Cmax as steady state, we are going to use C peak divided by e to the negative k tau t. So to calculate my Cmax at steady state, we have to know what is the trough. What we have to calculate, what is the trough time. So first, here C peak. Your C peak is going to be, what is your C peak is 3.48 divided by e to the negative k, e to the negative k 1264 times delta t. So here we have to calculate delta t. You know how to calculate delta t, same as before. In this case, let's take a look again that how to calculate delta t. In this case, delta time for this is Cmax and this is your C peak. You see, this is Cmax and your C peak. Your C peak time was what? It is 2200. Okay, but infusion was started at what time? At infusion as 22. This is 2200. Infusion was start. So this is infusion was start at 9:30. So let's see, type delta ts. It is 5 minutes. So delta in t trough. So the infusion started at 2100 and then it was infused for 30 minutes. 30 minutes. So and then your new time is 21:30. So Cmax would be 21:30. So and then delta t would be 2200 minus 21:30. Let's look into it right here. You have to look into the dosing interval. In this case, for example, here for this med, when it started at 2100, that means an infused, you start at 2100, infused for 30 minutes, so which would be to 21:30, and where you will have your Cmax, and then a little later at 2200 you took the sample, so this would be your delta t, and which is 0.5, and this should give you something 3.70 milligram per liter. So this type, and then in case of semen, it may confuse you, but you be careful. It is just, you see, when I was teaching, I was saying, okay, the T trough will be taken little after, but in this case, you see, here T trough is 2100, and the dosing interval also at 2100. That means you have started the dose. Your Cmean when is 2100, and soon after, at the end of the dose, you collected my sample and administered. So there is no time difference. In this case, it's kind of tricky. So that's why you have to do the calculation. Delta T would be, for Cmean, delta T would be 2100 minus 2100. That means 0. So in this case, your delta T is going to be 0. So for this reason, so now if you are going to use this calculation, this equation, Cmean is equal to C trough times e to the negative k delta T. So as you can imagine, C trough and Cmean is going to be the same. So here 1.85 times e to the, which is 0.1264 times 0, and this would be 1. This 1.85 times 1 is going to be 1.85 milligram per liter. In this case, when you see this, there is no difference. The delta T is 0. It's easy to, okay, it's going to be Cmean is same as this Cmean as study. The Cmean and C trough is going to be the same. Does it make sense? You may get confused, but I will go over this thing again. And this particular confusing and tricky thing, and I'm glad this assignment I have, this came out tricky one. So in this case, we have been talking about that you take T trough, C trough and Cmean. We have been telling that there will be a time difference, but in this case, Cmean and C trough sample was taken during the Cmean time. So that's why there is no difference. When there is no difference, in any case, C trough and Cmean is going to be similar. So here, that's why when we use the equation Cmean is equal to C trough times e to the negative k delta T. When you know that when this is 0, this part is 0, then this e to the 0 is 1, and then is going to be the same. Cmean and C trough is going to be the same. So always you have to do the calculation. Don't assume that, okay, I know this is 30 minutes, this is 0, so you have to always look carefully, because this is a tricky one, and this also confuse you when you are calculating the T trough minus, if you are calculating, for example, that now assume that you started this, okay, 2100. When you administer the drug, it's 2100. You have administered the drug at 2100, and then you stop at 30 minutes, which is 2130, and then you took sample at 2200. So if you want to move this, always you look into the trough sampling time. Trough sampling time is this one. Do not get confused with the other one. In this case, although same, it could have been instead of 2100, it could be 2030. So in this case, you add a dosing interval, which is going to be 6. Always you have to remember that you add a dosing interval with the, to be consistent. Always you add a dosing interval with the trough time. This will give you new trough time, and then subtract. In this case, our case 2100 plus 6, this would be here 030. That means trough sample was taken at 10 p.m. Sorry, peak sample was taken at 10 p.m. and trough sample was taken at 3 a.m. So time difference is 5 hours. So now the volume distribution, the same equation for my steady state. You have to calculate V as steady state. The equation would be R0 divided by K, and then let's see that equation. I think it is Cmax K Cmax infinity times 1 minus e to the negative K. What is the other equation? Negative K VSS steady state. What is that equation? Intermittent inflation. Yes, K in case of at steady state, we have to use this equation. This one. Kt infinity and then 1 minus e to the negative K tau. So for this we have to do again some little calculation. We have to find out infusion rate. Here infusion is given at 60 milligram per half an hour. So you have to calculate, it is 120 per hour. This, if you do not do this calculation correctly, then you will have wrong answer. So always you convert it to hour. So once you know all these stuffs, then things are easy. Here, in case of R, you put 120. K would be 0.1264 times Cmax. We had before Cmax, I guess it was 3.70 times 1 minus e to the negative 0.1264 times this infusion time is 0.5 hour, and then 1 minus e to the negative 0.1264 tau. Tau means 8 hours. I think it is. Oh no, it is 6 hours here. So here it is 6 hours. And this should give you an answer of 29.5 liter. And then when you have volume distribution, clearance is easy. CL is equal to K times V is going to be 0.1264 times 29.51 is equal to 3.72 liter per hour. You have to convert it to milliliter, which is going to be 62.15 milliliter per minute. So this is how you do all the calculation using for steady state. I will go over this again. So first thing, you have to calculate T trough minus TP, and you add dosing interval, in this case our 6 hour dosing interval to the trough time. So it will give you new trough time, and then you subtract this. It will give you this is going to give you T trough minus TP. So then you calculate your K is in that equation. This is easy. Here in case of Cmax, you have delta T was 0.5, because if you look here, your peak sample was 2100, and dosing was started at 2200. Dosing was started at 2100, and it continued for 30 minutes. So you have Cmax would be at 30. This 2100 30 minutes, and then you took a sample at 22 hours. So here this would be your delta T. Delta T would be 22 minus 2130 would be 0.5 hour. But in case of Cmin, it's 0, because if you look, always I'm just trying to emphasize this, if you look here, dosing interval, the time dosing interval ended, sample was taken. So that's why your delta T is 0 here. So it could be anything. So you have to always careful that this is dosing interval, and this is always, this is the start, and or you can say start. So because it is giving always time. So here 1900, then 1500, then 2100, and then 3 hour. So what is happening in this case, they took the sample the same time when they administered the drug. So that's why there is no difference between C trough and Cmin. To calculate volume distribution, you have to use that complex equation. That equation V is equal to R0 divided by K Cmax at steady state divided by 1 minus e to the negative K T infusion 1 minus e to the negative K delta, no, not delta, it is tau. So here it is tau. So you have to calculate R0. R0 in our case it says 60 milligram per 30 minute. In this case you have to convert 120 milligram per hour. And infusion time, tau, go back, tau is 6 hours. Q6H. So tau is 6 hours. Infusion time is 30 minutes. So and then you replace this equation with those data, you should get the V, which is volume distribution at steady state, and this is the equation, correct equation or accurate equation. And once you have V, you can easily calculate clearance. And always remember, for some reason Dr. Mahavar, when he was preparing a clearance, always needs to be converted to milliliter per minute. So always be careful with the unit. Everybody make mistake in unit. I do too. So this is all about intermittent IV infusion, and with this we are done with all the videos and related things with intermittent IV infusion. I hope this helps. If I have made any mistake, just let me know. If I've misspoken or it was confusing, so just let me know. it would help me and it will help you next generation student. Thank you.